This is example 1.8-1. An angle bracket having a thickness T equals 0.75 inches is attached to the flange of a column by two 5/8 inch diameter bolts. A uniformly distributed load from a floor joist acts on the top face of the bracket with a pressure P equals 275 psi. The top face of the bracket has a length L equals 8 inches and width B equals 3 inches. Determine the average bearing pressure, sigma B, between the angle bracket and the bolts, and the average shear stress, tau Aver, in the bolts. Disregard friction between the bracket and the column. So we have this structure here with a uniformly distributed load right here, and this is the angle bracket that the problem is talking about right here. And it is shown again in the second image right here, and we are given the values for the load as well as the dimensions of the area over which it acts. So we have B and L as well as the thickness of the plate T, and then there are two bolts that go through the bracket and we're given their diameter, and we are asked to find the bearing pressure between the bolt and the bracket, and that'll be the contact surface where the bracket and the bolt are touching each other, mostly on the top of the bolt since the bracket is pressing down on it. And then we're also finding the shear stress, which is the cross section, acts over the cross section of the bolt. So let's write down our givens and finds. And following our homework formatting, we draw a single line after we write our given and find. And now we are ready to start the problem. So let's start with our bearing stress, sigma B, and this is the stress on the surface between the bolt and the bracket. So that is going to be acting on the top of the bolt since the bracket is pressing down on the bolt. And so we can think of this as a half cylinder that kind of goes around the bolt. And so we have our force acting over that area. And when we divide the force by the area, we get the stress that is acting on that surface. So we have a force per area since this is a stress. And the force is going to be our load, and the area is the bearing area, so the area between the bracket and the bolts. And the force, to be able to find this, we're going to multiply this load, which is actually given as a pressure. We're going to multiply it by the area over which it acts to get the total force, and then we'll divide it by the bearing area to get the bearing stress. So this force here is going to be the pressure times its area, which is given as the area on the top of the bracket, so L times B, and so there's the dimensions of that rectangle. And so this expression here is the force, because it's the pressure times the area over which it acts. And then we divide this by the bearing area, which is a different area, and that is between the bolt and the bracket. And if we just draw this out, we have our little half cylinder where the bracket is pressing down on the bolt. But when we find our bearing stress, we actually use a projected area. And so that turns into a little rectangle. It is basically the area of that half cylinder looking from above. So the force is coming from above, and we find the area that is perpendicular to that. So basically looking down at the bolt, finding the area that you would see. And so what are the dimensions of this little rectangle? So This length here is not going to change when it's projected. So this side is going to still be the thickness of the bracket. And this one is actually the diameter of the bolt. So our bearing area is actually going to be the diameter of the bolt times the thickness of the bracket. And then since we have two bolts, we have twice the area it's acting over. So this is our bearing area, and this is our force that is acting on it. And so now we can go ahead and plug in all of the values. And this turns out to be 7,040 psi, which we can simplify to 7.04 ksi, which just means 1,000 psi. And you can just replace the p with a k. And that is our answer for the bearing stress. And so that's not too difficult. And now we're going to do the average shear stress, which is going to be the same force but over a different area. So we're going to call this the shear area, so give it a subscript S. And this is going to be, instead of acting on the outer surface of this cylinder, it's going to be over the cross section of the cylinder. And so again, our force is going to be PLB multiplying our pressure over the distributed area, and our shear area is going to be the cross-sectional area of a bolt, should be pi d squared over 4, and then we have two bolts, so again we multiply it by 2, and if we simplify this, we're going to get 2PLB over pi d squared. Right, so the 2 and the 4, they simplify down to a 2 on the numerator. And then we can plug in our values. Oh, and I forgot to mention that we should check our units. So we can see all of these inches cancel out, and we go from PSI to PSI, so that makes sense. And the same goes here. This is an inches squared, so this actually cancels out both of these inches, and we end up with a PSI. And this is equal to 10,800 psi, which is equal to 10.8 ksi. And there is our last answer. Let me do a double underline at the end of the problem. And that is it.